So the way we'll do this is I'll kind of ask and I'll let y'all like throw out some stuff and then I'll write down like the answer that I have. But a lot of times the stuff that you say would also be sufficient. So what is statistics or what are statistics?
A numerical summary of data.
So another way, or the way I have it, is a way of reasoning or methods that help us understand the world around us. What are data?
Numbers of context.
Yep, numbers with context. What are 3 simple steps to doing statistics right, according to the authors? I don't remember if we talked about that or not.
I don't think we.
If we did, it was very briefly, probably the very first day. It's think, show, and tell.
I think we wrote it down, but I don't think we
Yeah, I was like, because we didn't really like write any notes for chapter 1. Like we just kind of like talked about stuff because like there's not really like that much in chapter 1 other than literally those 3 things right there. So.
You know, after you go to Chick-fil-A and you just feel like you smell like it.
Mm-hmm. Talk about when you work there.
Yeah, I don't think that.
I still have like my Chick-fil-A clothes, like, cause anyways, long story, I didn't turn them in, but I still have them and they still smell like Chick-fil-A. Like, it's really gross. Did you forget your stuff?
I just came back up here.
No. All right, what are the W's and H of data? Who, what, when, where, why, and how. Why must data be in context, like the W's? Like, why do we have to have it in a context?
To like understand a problem more, I guess.
Kinda, yeah. Because data without context is useless.
Oh, be in context.
Without context, we just have random numbers, letters, etc. So, explain the difference between a categorical variable and a quantitative variable, and then give some examples of each. So, categorical is what kind of variable?
Yeah, or like put into a group.
When a variable names a category or categories and answers questions about how they fall into categories. And then before we do quantitative, what are some examples of categorical?
Like a jersey number, and like, yeah.
What'd you say? Dog breeds. Breeds. Gender. Zip code. Etc. We'd list other ones in our notes, obviously, but just to give a little refresher. So then, quantitative variables, what are they?
Like things you can count, I guess, like any kind of like
I know what you're trying to say, yeah. Measured variable with units.
Yeah, that's basically
This other part was also what you were saying. Answers questions about quantity. So what are some examples of quantitative variables?
like the number of dogs, or like
Well, that still would be categorical.
Lies. Like how much something costs, or
Prices.
tax, or
So prices, gas mileage. It's hard to come up with them sometime when
No,
you're
like,
trying to,
on
like,
the
you
fly.
see it and you're like, okay, I know what that is, but it's like hard to just come up with them. Time, length, etc. Obviously, we listed a few in the. I know sometimes I'm sitting here and I'm like trying to come up with examples and I'm like, oh my goodness, like I can't think of any like off the top of my head. It's annoying.
oh my gosh, this is gonna be so bad. I'm so bad at like anything that has to do.
Well, so what I do for the concept questions outside of like multiple choice questions is I copy and paste the exact question. So if you like know the questions from the thing, like you'll be fine. So,
Because if I like studied this, then I would easily be like.
yeah. Well, that's why I kind of
Well,
do
I
it
would
like
get my
where
notes.
I will like ask you like to try to give me the answer to see like cuz that way it kind of like just off the bat, did I know what that was? Like how much time do I need to spend on it too? So all right, explain the difference between a frequency table and a relative frequency table. So what's the frequency table? Or what does it tell us?
One tells us percent and one doesn't.
Okay, so which one does that?
Relative tells us percent.
Yep. So the frequency is the totals or the counts. And category names. The relative frequency tells us percentages of all values in the category. Now, the next couple of questions, they're like, when is it appropriate to use in the different kinds of like pictures? So there's obviously going to be like different scenarios, but I'll tell you what I'm kind of like looking for with those ones as we go through them. All right, when is it appropriate to use a bar chart?
I want to say when you're comparing something, but that's for like all of them.
Well, that is part of it is comparing. What kind of variable do we use with the bar chart? No, that's science. That's the same thing you did when we were going over the section. Categorical or quantitative?
Categorical.
Yes. This is for displaying
That's funny.
distribution of a categorical variable it's easy to do a side-by-side to compare. So the bar chart, it could just be like one set of data, or we could have two sets of data going side by side so we can compare it. When is it appropriate to use a pie chart?
Categorical. And then like, if you don't have to be specific.
So I think a pie chart could probably be either type of data, but we did talk about it more in terms of categorical, so yeah. To give a quick impression of how the whole group breaks down into smaller parts. In terms of like the percent of it that it breaks down. When is it appropriate to use a contingency table? Do what? When we compare like two sets of categorical data.
I remember when we were sitting at lunch and I was watching them study for this and I was like, oh my gosh, I'm so glad that's not me. And now this is me.
The thing is they talked a lot.
That's true.
So, like, it just took so much longer to get through stuff.
Yeah.
Because they would just talk and talk and talk. Like, there wasn't many days that we didn't do anything.
Yeah.
Like, they could have had more days to, like, work on their homework and stuff, but they
Instead
just
of only having
talked
30
and
days,
talked
they were
and
very
talked
busy.
and talked. It's like,
I remember when they were telling me about how many sections they had to finish before the exam, and I was like,
well, and part of it was we lost so much time last year.
Yeah,
that was a
that's
big
true.
one. That was hard. But college stats is easier than this AP stats. I'm not gonna lie.
yay. Love to.
What does a marginal distribution show?
Isn't it like the difference between them? No, that's definitely wrong.
It's something that's in the margin of the table. So what would that show?
Oh, wait. It's not a gap. That's not a gap.
It's like how many of like everything, right?
Kinda, yeah. Totals in each category.
Okay, that's what I thought, because I got that wrong on my quiz.
What'd you
I got an 87, but I missed this question because I thought like I didn't understand what it was saying, so I did like the gender of the breeds instead of the actual like number of the breeds.
And then how does a segmented bar chart compare to a pie chart?
They both show. They both show the totals in each.
Kind of. I think I know what you're trying to say. It looks at the whole.
Yes,
Yeah, it's like when you miss the question, you're like, oh yeah, that's what I meant.
But breaks into segments. So you can see the whole thing all at once, but it's split into different chunks so that you can see it all like added up together. Well, we're halfway through. We've done 3 chapters. All right, chapter 4 stuff. So what is meant by a distribution? This is probably not something, because we didn't necessarily talk about it this way that you're going to realize, but.
I don't know how to explain it without using the word distribution.
Quantitative variable that includes bins and counts. That's not a question I'm likely to ask you because it's just like, it's confusing on how it's like worded. Explain the difference between a histogram and a relative frequency histogram. So what would a histogram show?
Just like the numbers of data, and a relative would show the percent.
Yeah. So histogram is going to just display the counts. I literally can't spell today. Displays counts. The relative frequency one is going to display percentages. So in what ways are histograms similar to stem and leaf displays or plots?
They show like but they show like the stem and leaf plot. You have your min, your Q1, all those, and then the histogram also kind of shows that a little bit. Oh no, it doesn't. I'm thinking about scratch everything I just said. I'm wrong.
I was like, they do show something. So they visually look the same. At least when you flip them, they pretty much will look the same. They'll show you how many's like in each like little like spot basically. And they're both just ways to display quantitative data. When describing a distribution, what 3 things should you always mention? Or, I mean,
Shape,
4
center,
if it's there.
spread, right?
Yeah. Shape, center, and spread. And then, yeah, I would say outliers, if applicable. What should you look for when describing the shape of a distribution?
Gaps and outliers. Oh, wait.
Whether it's unimodal, bimodal, uniform,
Yeah.
all those things.
Unimodal, bimodal, uniform, symmetric. And then if it is skewed left or right as well, we'd want to comment about that there. Just more of a FYI, sometimes with number 5 on the test or a quiz or something like that, what I will do is I will actually tell you to draw each of them and what they would look like. So like how we did in the notes. And then I may ask you to like show one that's skewed right or skewed left. You also could, on the concept part, do you remember the questions that we did that said like the ages of people at like a little league baseball game or something like that? You may have some type of question like that as well on the concept part, because that's not really math. So just, again, with something like that, make sure you explain why you did what you did, because there are sometimes, depending on how you reason through it, like there may be more than one right answer or like justifiable answer. So in general, what is meant by the center of a distribution? Or like what are we talking about when we say center of a distribution?
Like IQR and spread.
That's number 7.
Yep.
Number 7 is IQR, standard deviation. So what things go with number 6 then, the center? Yeah. I'm going to write it as
That's what I was
median
gonna
and
say
mean so
next.
that they're in the same order as they are with the question below. So remember, median and IQR, or mean and standard deviation, go together. Also with the concept part, make sure you know like what happens if the mean is greater than the median, or if it's less than, or if they're equal. Make sure you know what those things mean as well. When is it appropriate to use a time plot to display quantitative data? So this, we didn't really talk about these because they really don't come up that much, but it's time plot when it happens over a period of time, basically. So with a time plot, I kind of think of like if you ever look at like your weather like app and you look at like the temperature as it goes throughout the day, like that's kind of like what I think of when I think of a time plot. And then what is meant by rescaling or transforming data, and what is the purpose of it? Or what is rescaling help us to eliminate, I guess?
Outliers.
Potentially, but what is the other thing? If it's not unimodal, or if it's not symmetric, it's what? Skewed. So it helps to make a skewed distribution more symmetric.
I would not remember.
And it can do the opposite as well. If you have something that's symmetric and you want it skewed, you could theoretically do something for that to happen. Which I don't know why you would want to, but you could.
I gotta tell somebody this. We was watching the Crucible English class.
I actually like that movie.
Everybody was crying.
I heard about that at lunch.
My class too.
Everybody was crying when they hung everybody, John Proctor and those other two. Everybody was crying, and then JR, I looked at JR, and he just smiling.
No.
Bro, he just smiling. And I look at him, and I try not to laugh. I mean, I did a good job trying not to laugh. But it was so, it was funny.
That's-
Everybody in my class was sobbing. I was like, guys, come on. Like, it's a
It's not
movie.
this.
Like, it's really not that tragic.
Emily cried, Peyton cried, Holly cried, Miss Patton cried.
Oh yeah, Miss Patton was sobbing during ours. I was
And
I don't think my class cried when we watched
Chase
it.
was just like, okay. And Brandon was like, dude, what's happening? I don't know what's going on.
I was looking at Miss Patton, and I see her doing this.
Dude, she does that. She'll literally
I see her
sit
doing
there.
that. And now just looking at her, like, just smiling, trying to laugh. And she look at me, I quickly look away.
So she doesn't see you laughing.
So,
There were so many people who were asleep in my class though too. They were just like, dead. I was like, oh, okay. And then Miss Patton was fucking.
All right, chapter 5. Explain the difference between range and interquartile range, and why is the interquartile range often a better measure of the spread of a distribution? So what is range?
Range like includes outliers, so it's like range is like all of the numbers.
Yeah,
Like,
so
including your outliers.
yeah, so it shows how far apart two extremes are. And then IQR. It allows us to ignore extremes. And concentrate on the middle of the data. Helps to ignore outliers.
I was struggling trying to figure out what interquartile range was.
I know, I was for a second too, and I was like, wait.
Yeah, because we call it IQR so much. So range is like max to min. Interquartile range is Q3 to Q1. And just because no question on here does it, what is the formula for outliers? For finding them?
Like Q1, minus, 1.5 times your IQR.
And the other one?
Q3 plus 1.5.
What are some advantages of box plots?
It can like show you your outliers too, and like it like shows you everything, just not the numbers necessarily.
Yeah.
Like it does, but like.
It can help compare data, which would be what you're trying to say there, I think, and then allows us to see outliers. So it's something like this, and it shows you your min, your Q1, your median, your Q3, and your max. And if there's like a little star or something, that would indicate an outlier if it's there. I think for number 3, you kind of just mentioned it with what you were saying with 2, but what are some disadvantages of box plots?
It doesn't necessarily like tell you the exact number.
Yeah.
So,
It can be hard to read the values. It's a simple summary of a distribution. When is it more appropriate to use the mean as a measure of center rather than the median?
it's skewed, lies. If it gives you standard deviation.
What's true about the shape of it? To use the mean. It needs to be what?
Symmetric.
And
Uniform.
other
Yeah,
one.
That's for histogram. Use mean.
Well, we are talking about a histogram, basically.
Yeah. Mean when.
You're right about symmetric.
Symmetric.
Standard deviation. Or the IQ portion.
No, it's another thing about shape. How many hills can it have? 1, so it's unimodal.
Gosh dang it. I said uniform.
But see, the hope is that getting it wrong now, I mean,
Oh,
you
yes,
know it
I
next
will
week.
remember
And just a quick, I mean, I think y'all know this probably from like elementary school, but the formula for mean is the total divided by n, which is the number of elements that there were. Another way we write it is the summation of y over n. And that's what gives you the mean. So then 5 is the reverse. When is it more appropriate to use median as a measure of the center rather than
When
mean?
it's skewed, or all of the other.
Yeah, multimodal or skewed. And it's resistant to outliers. Just a note. By using the median. When do the mean and median have the same value? When what's true of its shape?
I know we wrote this down.
We said something about when mean is greater than the median, something happens. When median is greater,
It's skewed left and right, and then I can't remember the last one.
what would be the other option if it's not skewed
Symmetric.
left or right? So when it's perfectly symmetric.
Can I go fill my water really quick?
Yeah.
I know the answer.
The next one I don't think we actually talked about. We should have, but we didn't, so.
Probably.
I don't think we talked about variance at least. So, but it's important, so.
You know, I was looking at my calendar today. We only have 7 more weeks left of volleyball.
You went all the way through you went all the way through state, right?
No, I didn't. But including state.
Because the last state game I think is like November 11th or something like that.
Oh gosh.
State finals are like November 11th.
So November 11th.
So we have 2 months
so
left.
Add like 2 more weeks to that, so 9.
All right. For variance and the relationship between variance and standard deviation, I don't think I actually mentioned that, but I
I don't think you mentioned
probably
it.
should have because we talked more about variance. I think it's in the next unit it comes up. But it only works for symmetrical data.
That's the easiest man.
That's what I'm saying. I can't wait until Monday night.
What's up with everybody giving out exams on Fridays?
Because they can't give anything on Thursday.
What? That's what
Yeah, you can't have homework on Wednesday.
I'm talking about. Wait.
Like, so everybody makes up for
Uh,
it by giving stuff on Friday.
so
And then there's things that are like every week, like a certain day, like Fridays, like pretty much always vocab. It used to always be a Bible verse quiz, but I think they said that's like Wednesday now. But like it's like always the day that like everything just falls on. I try to not give as much stuff on Friday because of that, but sometimes you just can't help it. Like I mean I can't push everything.
They like hate having tests on Monday and stuff, but like I really don't mind. Like I'd much rather have it on Monday than Friday.
I'd rather have it in in the middle of the week, like
Yeah, like a Tuesday.
Tuesday or Wednesday.
So like this test is gonna be perfect then. Standard deviation is how far each value is from the mean. It is the square root of variance. So the formula for variance, which is s squared, is equal to the sum of y minus y bar squared over n minus 1. And then standard deviation is that, but the square root of the whole thing. So standard deviation is just S, and it's the square root of the summation of y minus y bar squared over n minus 1. So everything's under the square root there. So if you're given variance and you need the standard deviation, you take the square root of it. If you're given, well, like I said, it'll come up more later, but there's times where you have to change your standard deviation to variance before you're allowed to do something with it, and then you have to change it back. But that's like next unit. That's why I said, like, it's important to mention it now so you've seen it, but it will actually do stuff with it in a later unit. I think it's the next one, but I could be wrong about that. Chapter 6. All right, what unit of measurement is used to describe how far a set of values are from the mean?
Like centimeter.
I was gonna say
No. How far something is from the mean? What is that?
That's distance.
In terms of stats. That was word we just mentioned in the last question. Standard deviation.
for some reason I thought you said standard deviation in the question, so then I was like, wait a second, and then I reread it and it's not in the question. I almost said pounds. Like I almost did. Because I kept being in every single one of our problems. I was like, well, maybe. But then you said centimeters, and I was like, well, pounds can't be right then.
That's funny. How do we standardize a value? We made a fancy table for it.
Or curve. No.
Table.
Oh, table. Right.
Last letter of the alphabet.
Z-plot.
Z-score.
Score.
The formula for Z-score is what?
Z equals is the fancy U minus no something minus the fancy U over
Over the upside down 6. What is it called?
Sigma.
Yeah.
sigma.
So yeah, so it can either be y minus y bar over s or y minus mu over sigma.
U
They,
over sigma.
literally-
Alphabet is terrible.
huh?
I agree the alphabet is terrible.
I was gonna say there's a poster on the wall for it, but I don't have that poster up.
All I know
I think you should put it back up.
like my brother,
I don't even know. I think I still have it, but I'm not positive. It was Mr. Cass's, so.
like my brother, he tried to pledge, so he has to learn the Greek alphabet. He recited it every single day for some reason. It just did.
I know some of them, but I don't know all of
I
them.
should remember alpha, beta.
Gamma, epsilon. I don't know them in order, but I know a lot of them.
Like,
One of my professors in college was actually Greek, so he was like, people pronounce these things wrong, and I was like, okay, buddy.
Okay, buddy, I'm gonna him.
How does adding or subtracting a constant amount to each value in a set of data affect the mean?
Oh, I remember, but I don't. I remember talking about it. Okay, so adding a constant amount to values in a data affects the mean. You have to add that amount, but it doesn't affect the standard distribution or IQR. But that doesn't.
That's going to be this question, but yes. All right, so for the mean, all measures of position, talking about mean, or the center, the min, the max, will increase or decrease depending on what you're talking about. by the same constant. And since we already said it, for the standard deviation, the spread, meaning IQR or standard deviation, stay the same. When adding or subtracting. What happens to the mean when we multiply or divide?
It multiplies or divides by the same constant.
All measures of position are multiplied or divided by the same constant. And then what's true about the spread values?
Everything changes.
The spread are multiplied, oops, wrong symbol, multiplied or divided by the same constant. How does standardizing a variable affect the shape, center, and spread of its distribution? So that's just saying when we, well, this is a different way than what we've worded it, but the shape stays the same, but the center changes by making it 0. Changes, making the center 0. And then the spread changes, making the standard deviation 1. So standardizing is like when we took this up and we made them z-scores, basically, is what that's talking about. It just was worded a little different than the way we talked about it. In what way does a z-score give an indication of how unusual the value is? So what did we say? How many standard deviations away do we consider unusual? Yeah. So anything 2 standard deviations away is considered unusual. It tells how far away from the mean we are, or how far we are from the mean. A z-score close to 0 is close to the mean. We only have like 3 minutes. I'm trying to like power through these. Did you study?
Oh, forensics test? Literally.
Do you study for anything?
Okay. No, I barely study for that.
Dude, I have to study so much.
Like studying is just I don't like
I hate doing it.
you either pass without studying or fail without studying. That's my motto.
How would you describe the shape of a normal curve, or like what does it look like?
Like an ice cream cone.
It's fair.
Like measuring cone.
It's officially called a bell curve. You can think of it however you want. I usually call it a little hill.
I want to say draw, like I said, explain.
Well, it says how would you describe it, and then it says to draw an example. So, I call it a little hill, but whatever you think of is fine. When is it appropriate to use a normal model for a set of data? When what's true about the shape? I'll give you a hint. It's the same as the other ones.
It's symmetric
And
and unimodal.
yeah, when distribution is symmetric and unimodal. Okay, for the empirical rule, okay, it's just the 68, 95, 99.7 rule. It's just how many standard deviations away it is. So 1, 2, and 3 standard deviations away.
That one actually.
I can't even spell anymore. I literally put every. I had every vowel wrong in there. Is there a difference between the 80th percentile and the top 80%? We can just do these last two on Monday, if you want. Or if you want to come and take a picture of like the last page of mine, just so if you wanted to go over it, but it's just two. Just remind me on Monday that we need to finish.